Today I want to show you a micro UAV that I came across recently at the USC conference in Montreal. It's called the AgilCoptor and it's made by a Newfoundland startup called Agile. The technology was developed by people at Memorial University. I haven't seen this quad in action yet, so I can't attest to its performance, but I thought it was interesting enough to show you.
It's designed to be insensitive to disturbances. We're targeting using this to do inspection in harsh environments, harsh Arctic environments. We're looking at gusts in the order of 50 kilometers an hour that they can withstand. Autonomy is about 30 minutes. The motors are shock mounted to the board, and the camera is typically shock mounted as well, just to minimize the vibration. Also, it integrates a camera, a 3 megapixel camera, and we're able to do onboard image processing in this 350 gram package. It's a single printed circuit board design, and the structure is actually the printed circuit board, so it can be mass produced using standard circuit board assembly techniques. We can accommodate about 300 grams of payload, so in your particular case, a GoPro may be possible. An additional GoPro camera we could probably put on. It weighs about 350 grams, but it has the performance of a much larger, more expensive unmanned aerial vehicle. And in many cases, it can be considered single use. If you can't recover it, it's not the end of the world. $4,000 to $5,000 at the moment. But again, it's all relative, because in many cases, for example, in the offshore, for the offshore industry, the most expensive thing that you're dealing with is ship time. So if you can reduce the amount of ship time, $4,000 to $5,000 may not be that significant. We've had interest from companies that operate windmills, wind farms, and they're interested in a small vehicle to be able to inspect the blades, let's say for ice damage. And if you look at what the alternative is now, it's getting a cherry picker, a relatively expensive device, so you can lift an operator in vicinity of the blade so they can do the inspection. The original idea was, well, we wanted our own sort of open source platform that would allow us to test some of our sensor technology. For example, we have an intelligent camera that we produce. So this device integrates the intelligent camera. So it really started as just a platform for our own use internally, but since then, it's taken on a life of its own, and we've gotten a lot of interest. This doesn't use conventional processors for control. A lot of the controls are built and are implemented in hardware, in devices called FPGAs, field programmable gate arrays, so it's a little bit different. So the control algorithms run at very, very high rates, typically 12 kilohertz. So that's what gives us the disturbance rejection. It's a very robust controller that's operating very quickly. And that's what gives us the improved performance.
Unfortunately, they weren't doing any demonstrations, so I can't comment on whether the performance of the craft is as good as they pretend. But I must say, as somebody who does a lot of low-altitude, short-range video, the idea of a smaller, lighter, maybe safer craft is very appealing. But $5,000, maybe I'll wait for the price to go down a little bit before I buy one. And in the meantime, safe flying.